Non-sequitur. Your facts are uncoordinated.
Warning. The following live stream is intended for an uncommon audience. Those suffering from religious celiotitis, idiotic use of the word scientism, or geoplanetary flatardation are advised not to watch any further, as this could result in symptoms including feeling triggered, loss of wokeness, or the need to comment in all caps. However, if you think bold ideas are righteous, unique perspectives are gospel, and strong opinions are sacred, then we say hallelujah. This is Non-Sequitur. Never follow. And now, here are your hosts, Kyle Curtis and Steve McRae.
You're on.
Cool. Hello, everybody. Happy, it's Friday, right? I think it's Friday, right, Steve?
It is Friday all day long until it's Saturday. Then it's no longer Friday any longer.
This is true. This is why you are the smart one on this show, and I'm just here to be pretty.
Can I be the pretty one? You can be the smart one. I don't mind.
No.
Damn.
Not giving it up. Anyway, welcome everybody to Non-Sequitur. I'm Kyle Curtis. Steve McRae is, I believe, to your left, or my left, and Dave is producing. And joining us, we have two very fine gentlemen. I'm going to let Steve introduce them real quick, and then we will talk about what we have coming up, and then a little something special before we jump in.
Well, tonight we got something really special. Now, as you guys know, we were supposed to have Rick Delano tonight. He wasn't feeling well initially, and he is doing better from what I understand. But things kind of changed a little bit. We actually have Robert Sungenis back with us. If you guys remember, he was the producer for the movie The Principal, and he had a discussion with Antonio Subarats, and now he's back, and he's going to be having a discussion tonight with Dave Palm. And Dave Palm runs a channel called Geocentrism Debunked. Actually, Dave and Robert have quite a bit of a history together. I believe they've had written discussions back and forth for each other for quite some time now. So to my knowledge, this is the first time they've ever engaged verbally with each other. I could be wrong on that, but we'll ask them. But Dave, you're new to our channel, so I want to welcome you to the Non-Sequitur Show. And if you want to tell people a little bit about yourself, then I'll have Robert do the same. We'll give you guys each 10 minutes to talk about your positions, and then more of a back and forth kind of free flow discussion. So,
and that will be after we introduce, or talk about what we have coming up, and then your things.
Yes.
Okay, so our introduction, and then what's coming up, or what's coming up first?
You want to do what's coming up first, Dave?
Yeah, we'll do what's coming up first. Real quick, and then we'll let you guys. That way, we just kind of go straight through, and there's no break up there.
Yep.
Okay, so if Dave will, like I said, I can't see what we've got on the screen because of the new software. So, Dave, I'm going to trust that you are the capable man that I know you are, and we can do this blindly. Tomorrow, Tim O'Neill will be back with us. He is an atheist that runs a blog called History for Atheists. What he does is debunk arguments often used wrong in terms of debating, where he he's got quite a few enemies for that. He tends to correct atheists on some of the things they feel are the strongest pieces of evidence that they use in their debates, and so they don't like that too much. But he will be back with us tomorrow to talk about why Christians were not responsible for burning the Library of Alexandria, which is often said. Sunday, Tony Farrell, who is a University of Liverpool doctoral student in Egyptology, will be with us. We are going to go over some of the things that Brian Forrester said when he was with us last Thursday. Especially, Steve, I can't wait to find out the answer to whether or not we really could have an obelisk Wi-Fi receiver.
I'm going with no.
Are you sure?
Yeah. Final answer.
All right. So that will be Sunday, and that's at 8 o'clock Eastern. Monday, Robert Sungenis will be back with us again, and he will be going against one of the most memorable people that we've had on this show. People really responded to allegedly Dave. And actually, to a funny story, we usually let the guys that come on, if they ask, mirror the debates on their particular channel. And I believe this particular debate has close to 30 1,000 views on our channel. But on Dave's channel, it's got close to like 70. So Dave's killing it in the in the views there. And then on Tuesday is something me and Steve are looking forward to doing ever since we learned that this technology was out there. We will be having the creators of Soul Phone on here. And if you haven't heard Steve or I talk about Soul Phone is a technology that this company claims allows you to either text, call, or video chat with those who have passed on. And so we're going to see how that's...
Look at Robert's face. That's great.
How that's possible. And I can't wait to... Steve, do you know who you're going to call yet?
Ghostbusters?
Good answer. Okay. So that's all for what we've got coming up. Remember, guys, to follow us on Twitter to keep up with what we've got going on. We started every day now to do this thing called It's a Fact, where we are actually putting into meme form arguments used by flat earthers. So you can catch one every day on the Twitter. It's there. There's 3 up there now, so you can go check those out. Also, if you want to find out what's coming up next on this show, I think we usually try to stay 2 weeks in advance. You can go to nonsectshow.com/schedule and find that. And if you are a Patreon, thank you very much for your support to the show. We will be having our Patreon private hangouts that we do bi-weekly tomorrow at 4:00. So the link for that will be in the Patreon or on the Discord server. Also, if you leave super chats today, they will be read on the show. Or if you want to ask or make sure that a question gets asked, you can super chat that, and we will hold it to the Q&A session and make sure that it gets read. Okay, so back over to Steve, who has something very funny he wants to share.
I do. I was going to I was just going to ask you if you passed away and I had Soul Phone and I was contacting you, what is one thing you would let me know from the other side? See, I know what I would say. I'd be like, burn my hard drive. But
that I have instructions to do that before. I thought you were going to play a voicemail for us.
Oh, I sent them to Dave, but I don't know if he had them queued up. I have 9 of them
We can do that at the end or in the after show. Then.
So we're might have an after show. And what he's referring to is that I have a psychotic ex-roommate that you guys might remember, and he actually has been leaving some voicemails after our court case yesterday. So we'll fill you guys in on that later on the.
And by the way, this guy's probably going to kill Steve, so I'm looking for a co-host.
Yeah, I'm going to tell you right now, we are getting a restraining order. If for some reason I don't show up for several days, you might as well assume I'm deceased and he did something.
Put your application in at nonsectshow.com. Okay.
Well, Robert might be interested. Anyways, take my place. So here we go. So anyways, let's get into this. Dave, why don't you go ahead and introduce yourself? And by the way, I do appreciate that you coming in. I know we had a lot of correspondence to make this happen, and very much appreciative.
Yeah, it's my pleasure to be here. So yeah, my name is David Palm. I am an electrical engineer by training, BS degrees in electrical and computer engineering. I also have an MA in New Testament studies, so kind of a little cross-disciplinary thing going there. I do work professionally as an engineer. I'm an engineering manager for Train, the HVAC company. Nothing I say here can be attributed to my employer, of course. And and I have a wife. I have 4 children, and we live on a small farm in southwest Wisconsin. So I've been. I just looked. I wrote my first article on geocentrism in December of 2010. So it does go back a while. And the real impetus for me was the connection that the new geocentrists were making between geocentrism and the faith, the Christian faith, specifically the Catholic faith. And so I think we're going to be focusing mostly on the science tonight, but that was really the connection that drew me into the discussion, because I reject the claim. I reject the claim that the Catholic Church teaches geocentrism as a matter of faith, or that any Catholic, any Christian at all would be compelled to hold geocentrism as a matter of faith. And therefore, I think we need to then, of course, just look at it strictly on its merits. And that's what I think we're going to be focusing on tonight. And I think on its merits, geocentrism isn't tenable. So that's kind of it in a nutshell.
Awesome. And Robert, welcome back to the Non-Sequitur Show. And for those who don't remember you, why don't you go ahead and introduce yourself and your position in all this?
Okay. Well, I've been in it longer than David has. I started this track in 2003. when I had nothing to do one Sunday afternoon, and I went on the internet, and some PhD in astronomy was saying that the Earth was in the center of the universe and the sun and stars went around it. So I had to make a decision that day whether I was going to continue to press the next key that was inviting me in that website, or go outside and play some golf. And lo and behold, I pressed the key, and there I was in the midst of his massive information about geocentrism. So that's when it started for me. And I knew a lot of the physics because for a certain period of time I was a physics major in college. I've always been into science, and I knew what he was talking about. I could relate to it very well, and had a very hard time refuting the position the way he described it. The man's name is Gerhardus Bau, who's been a geocentrist for, probably 3 or so decades. And he's a Protestant, and I'm a Catholic. But he started me off on the trek, and then I began to get really, really deep into the literature. And I probably read, at least 500 books on this topic alone. And I learned enough of the ins and outs of it to be able to write my own first book, which came out in, I think, 2005, called Galileo Was Wrong, the Church Was Right. And then that had several editions, which I think we're on our 12th edition of the book. And the editions come out because as I gather more information and can explain it better, I just keep adding that to the book. So the book now is in 3 volumes and probably 2,200 pages, 6x9 frame. So you wouldn't expect something like this might get that deep, but it really does, because it touches a lot of other areas. And as David mentioned, it touches the church area. He said he got into it 2010 because of the connection to the church. And here's another point where we're going to disagree on. I do believe it is a matter of faith. And that was expressed in 1616 and 1633 by the church when they condemned Galileo as vehemently suspect of heresy. And you can't be suspect of heresy unless the church first calls it a heresy. They have to formally define it as a heresy, and then you can be convicted of that very heresy. So in that sense, it is a matter of faith, and we can discuss that later. So it touches a lot of areas. It touches the Bible, because the Bible says the earth does not move. And as a matter of fact, in Psalm 93, it says that God's immutability, his very own immutability, he uses the motionless earth as an analogy to that immutability. If the earth can't move, God can't move. God cannot change, you see. So scripture definitely becomes involved with this. The church scripture, then we go back to the patristics, the early fathers of the church. Now, I know you guys are atheists. This probably is going over your head, or you don't want to hear about it, but
he's the only atheist in the room, actually.
Oh, is that right? Okay.
He's a
Anyway,
deist.
so you go back to the fathers, you go back to the Jewish cultures, you go back to the Greeks, because they had 2 different opinions on this topic too. Pythagoras was a heliocentrist and Aristotle was a geocentrist. And we'll explain why they diverged later on in the program, I'm sure. So again, it touches a lot of areas. It touches, the cosmogony and cosmology of the universe, because they have satellites now that can look real deep into space, and they see certain things, and it looks like the Earth is in the center of the universe. Okay. As a matter of fact, part of my discussion tonight is going to be on those very things those satellites have discovered, including Edwin Hubble. Einstein gets into the picture, all kinds of physicists. So it's a big topic, and I'm not sure how much of a debt Dave and I can make into it tonight, but I'm sure we're going to give it the old college try and make it interesting for everybody.
Now, am I correct to assume that this is the first time you two have ever had a correspondence with each other vocally?
We've had correspondence, and but it's all been written correspondence.
Okay, that's right.
Yeah,
And I don't remember ever talking to Dave personally. I think we did on the phone.
Yeah, we've had a phone conversation before.
Dave, do you want to kind of jump on right into it? I mean, obviously Robert has said a lot of things, so do you want to pick on one of those things and kind of run with it from your point of view?
Well, I'll tell you what I'd like to do is I'd like to make sort of an opening statement, and then obviously, give Bob the same opportunity, because I don't think that was his opening statement per se, right? But
yeah, I just wanted to introduce myself. That's all.
Yeah, exactly. So, so the position that I'd like to discuss tonight is that basically the way I've characterized modern geocentrism, and again, I want to be clear about what we're talking about, is that the Earth is the absolute immobile center of the universe. So it neither orbits the sun nor does it rotate on its axis. It is in fact absolutely immobile and at the center of the universe. That's what we're really critiquing tonight. And the way I've characterized that on my site is to call that a massive exercise in special pleading, sort of gummed together with conspiracy theories. Let me unpack that a little bit. So in the Western intellectual tradition, we talk about this thing called scientific parsimony, where we're looking for scientific explanations that are as simple as possible, that are explanations that explain the most of the observational evidence with sort of the most observational phenomena with the fewest explanations. And we oftentimes attribute this to William of Ockham. We talk about Ockham's razor, right? But it actually predates him, and to a source probably more congenial to both Bob and me, and that is St. Thomas Aquinas. And I quote here, St. Thomas says, "If a thing can be done adequately by means of one, it is superfluous to do it by means of several. For we observe that nature does not employ two instruments where one suffices," end quote. So what I'm arguing is that on the one hand, we have a very parsimonious and reasonable explanation for a host of observable phenomena, and I'll list those here in a little bit. And that is just that the Earth orbits around the sun and it rotates on its axis. And that those two things by themselves, according to well understood, universally observed laws, most notably of gravity. We have that on the one hand. On the other hand, we have this modern geocentric model where the whole universe, ironically, is centered on the sun, and then that whole thing goes around the Earth every 24 hours. But in addition to that, you also have to have the whole universe kind of doing this wiggle wobble, rock and roll kind of gyration to get some additional observable phenomena. And then you have to introduce not one, but two different ethers that have to behave in all kinds of interesting and sort of unpredictable ways that are needed by the geocentric system, but then you can't actually detect them, in any other ways. And all of this has to conspire then to mimic the phenomena that we would expect and predict if we have the simple and reasonable explanation that the Earth orbits the sun and rotates on its axis. And what I'm arguing is that there's no compelling reason to abandon the parsimonious explanation and go with this, I call it the sort of Rube Goldberg glass-up of a universe. If you're not old enough to know who Rube Goldberg is, you should Google that and you'll get a kick out of it. Yeah, it's good. But so I don't mean to be insulting in this, but the discussion or the interaction with modern geocentrism, it actually reminds me a little bit of that scene in Dumb and Dumber, where he's talking to Mary and he's saying, so, I have any chance with you at all? And she says, it's not good. And he says, well, like 1 in 100. And she says, well, no, it's 1 in 1,000,000. And he waits a little and he says, so you're saying there's a chance? And I feel like that's what I run into when I interact with modern geocentrism, is that, and this actually happens, Bob does this with flat Earth, right? The flat earthers have an explanation for everything, right? They have an explanation. And that's what they put, bank on. They say, hey, I have an explanation, but what they're doing is they're putting their explanations on intellectual par with those that are more parsimonious, that are simpler, that are more coherent and harmonious. And Bob actually, here's a quote from an article he wrote called Flat Earth Frenzy, Unscientific, Unbiblical. He says, YouTube is filled with normal, everyday people who have become amateur scientists and producers, all telling us that society as a whole has been deceived into thinking that the Earth is round, despite the fact that almost every other celestial body we see in the universe, from our sun, our moon, the planets, or the stars, are round. A little bit further in the article, he says, this is precisely the problem with flat Earth science. Although it can produce various explanations that one might use to support a flat Earth in order to be the correct view, flat Earth science must be able to explain every problem that it faces. In fact, some of its explanations are not only bizarre, the medicine they purport to give us is actually worse than the disease they're trying to fight. So I submit that Bob knows and acknowledges the need for having, that he doesn't put all explanations on the same level, right? Some explanations are better than others. I think he's acknowledged that when he interacts with the flat earthers. But what I'm saying is you could actually, of course, substitute him into that first paragraph. YouTube's filled with normal, ordinary people who have become amateur scientists and producers, telling us that society as a whole has been deceived into thinking that the Earth revolves around or orbits the sun and rotates on its axis, despite the fact that almost every other celestial body we see in the universe, from our sun, our moon, the planets, the stars, all the less massive bodies orbit around the more massive bodies, and the massive ones rotate on their axis. And then we see that universally according to well-understood laws. So what I'm saying is that Bob acknowledges this argument from parsimony, and he's correct in doing so, right? Because that is a really important part of our Western intellectual patrimony. It's the basis for, true scientific study. But I believe that he abandons it when it comes to explaining a host of observational phenomena. So we're talking about basic orbital mechanics, right? The mass of the sun is, and the mass of the Earth, the distance of the Earth from the sun, its orbital period are exactly what we would predict if it was gravitationally bound and behaving this way. Stellar parallax, right? Stellar aberration, the equatorial bulge, okay? The wobble, the polar wobble, nutation, precession as the Earth rotates on its axis, right? These are all things that we would predict, we would observe, and we do observe them, and they are easily explainable. Now, he has an explanation, I grant him that, he has one. But what I'm going to argue this evening is that there's no compelling reason to abandon this simple, parsimonious explanation that's based on universally observed behavior in the universe, and that is that the Earth orbits the sun and rotates on its axis. There's no compelling reason to abandon that. To do so is unreasonable. And that's why I find modern geocentrism to be problematic. Now, there's other phenomena that I didn't mention. Probably we can get into some of those, some of the more advanced ones, but those are a lot of the classic arguments for the motion of the Earth.
Okay. And Robert?
Okay. I'm tempted just to dive in here and answer everything that he just said, but I'll try to constrain myself. I will jump off a couple of things he said to go into my description of geocentrism, because if the parsimonious aspect of this is the fulcrum upon which the debate balances, there's two sides to that story. Let me to introduce my topic, let me deal with this. We need it as simple as possible, the Occam's razor rule, okay? Actually, scientifically speaking, the heliocentric version is the more complicated version, because first of all, it has to have a rotating Earth that has to rotate on its axis exactly in a sidereal rate of time, which is 23 hours, 56 minutes, and 4.1 seconds. That's kind of hard to do when you're in the middle of the space and you're bombarded by meteors, you have earthquakes, you have tsunamis, you have volcanoes, which all increase or decrease the inertial forces on the Earth that will make it either slow down, speed up, or somewhere in between. And that happens every day. We have 1 million earthquakes every year around the Earth, okay? So, and then you have to have this Earth revolving around the sun in 365.25 days. And that has to be exact. And so not only do you have the Earth in itself being bombarded by all these extra forces out there, it also has to revolve. The sun then has to revolve around the galaxy. The galaxies then have to revolve around some other cluster of galaxies, and they revolve around some other cluster of galaxies. And then you have an expanding universe that is actually giving them many problems today. So you have this complex assortment of movements of all these bodies that have to be precise in order for the world to work right. That's complicated, okay? In the geocentric system, we don't have that. We have a very simple model. The Earth is in the center of the universe, and the universe revolves around it and carries everything with it. That's all there is to it. That's all we need. So that's simple. So if we're going to go by Occam, and nature will always take the simple path, we've got it. Okay, it's the heliocentrists that have the more complex one. I had to answer that because that was bugging me, okay? But let me go on with the introduction to geocentrism. As I mentioned in the beginning, my introduction, I said that because the church is involved in this, and everybody knows the story of Galileo. You have not been a member of this human race unless you've heard of Galileo from the time you were 5 years old onward. So you are immediately introduced to the fact that the church was against science, science against the church, so to speak, right from the time you're a child. So you can't escape this dimension of the discussion. And it's that very dimension of the discussion, in me being a Catholic, that motivated me to pursue this to the ultimate end, to find the truth. Because if the church is going to declare this man a heretic because he said that the earth went around the sun, I want to know why. Because this is the faith that I live. And that then gets you into the science of the whole thing. But the two are interconnected. And so basically all of history is interconnected with this thing. As we said, we go back to the Greeks, who were the first ones to have two different models. Why did they? Why did Ptolemy stick with the geocentric model? And then Copernicus come up with the heliocentric model, okay? So what I want to say is this thing is very complicated, and you have to sort through it fairly with each piece of evidence that you get. And like why I just went through this whole Occam's razor thing was because this is a stereotype against geocentrism that has been used for years, as if we have the more complicated model. And as a matter of fact, I think on the last show we did, I was talking about Copernicus versus Ptolemy. And here's another stereotype that we've been taught since we were children. And that is that Copernicus developed the heliocentric model, and this was the simpler model to Ptolemy's model, because Ptolemy used all these epicycles, all these circles that he had to put in his model in order to adjust it so that it fit what he saw in the sky. Copernicus had the same problem. As a matter of fact, he had more epicycles. Now, I know there's some disagreement among authors on this, but he had more epicycles in his model than Ptolemy had in his. So how could his heliocentric model be following Occam's razor, okay? So that got me moving on this again. Nobody had ever told me that Copernicus's model was a complicated model. And actually, when he got done, it didn't fit what he saw in the sky any better than Ptolemy's did, you see? So this whole thing has been a matter of development. Copernicus actually got his model from Aristarchus of Samos in Greece. And his was a simple model too. So basically, Copernicus just wanted to copy that. And as he copied it, he found out that it was a much more complicated than he thought it was, okay? Even today, if you talk to physicists, they will tell you that we still don't know how these planets move exactly. There's always perturbations out there. There's always something that they never expected that's going to come up that's going to affect these planets, okay? So as far as a compelling reason why I would persist in this idea that it's because of all these other places that you find the geocentric versus heliocentric model talked about. If the fathers of the church decided that among Pythagoras between Pythagoras and Aristotle, which one came the closest to what scripture said and what was passed down to these fathers, they decided it was geocentrism, okay? They had two choices. Why did they choose geocentrism? We need to know that. So there's one compelling reason, okay? The fact that Galileo was condemned of heresy or suspect of heresy, and other things that have happened in the church, that's a compelling reason why we would want to. So why would the Holy Spirit lead the church in believing in geocentrism for 16 centuries or what, 19 centuries. And all of a sudden, somebody comes up and says, well, you know, that model's wrong. And so the Bible really can't be interpreted at face value. It has to be interpreted metaphorically because the Bible really says something wrong in that area. So the question is, why would the Holy Spirit lead us into that direction and then suddenly pull the rug out from under us and say, well, I'm sorry, folks, it was wrong the whole time. You know, I really didn't do my job in leading you astray down this path, but I'm glad somebody actually came along and fixed it. So that's the compelling reason. The reason is to save the veracity of the church, to save the veracity of its history and its tradition, and to show that, you know, we weren't misled. We were led down the right path from the beginning, and the burden of proof is on those who think otherwise. And using Occam's razor is not going to be the solution, because Occam's razor also defeats their argument, okay? So, and this whole, you know, when we grew up, we were taught by, as little children in school that, you know, the earth has to go around the sun because the sun is bigger and the earth is smaller. And we can prove this by looking out into the sky. As a matter of fact, Galileo himself thought he proved it because he saw the moons of Jupiter going around Jupiter. And so he figured that, well, if that's the case with smaller moons going around a large planet, that has to be the case with the earth going around the sun. And normally speaking, we could all agree with that. If we limited the system to a sun and 8 or 9 planets, whatever you believe about Pluto, if we limited the system to that alone, I would be dead wrong about the earth being in the center of the universe, because it would have to be the case that the earth would go around the sun, okay? And when Newton proposed this to the society at large, he had certain parameters that he had to follow. One was he needed space to be absolute. In other words, space could not move. It was absolute. That meant that he could never have a rotating universe that the Greeks believed in, that the church had believed in. He made it absolute. Okay.
Robert, let's give David a little bit of chance here. We're going to need 10 minutes. Wait,
can I just, yeah, wait.
Yeah, you finish up this. I just want to overload David so we can address each point individually. So go ahead and wrap up your point on here, and then we'll turn it over to David.
Okay, give me about 2 or 3 minutes.
Okay.
So he had his absolute space, and if you have absolute space, that means you don't have a rotating universe. Then it's the bodies themselves that have to move. There can be no body that's not going to move. And in that system, that's what he needed. But he just assumed that space could be absolute. He didn't know that, but he needed it for his system. A couple hundred years later, a man named, excuse me, Ernest Mach, excuse me, Ernest Mach came along and said that Newton had no right to say that space was absolute. In other words, he had no right to say that space could not move and that only the celestial bodies could move. Einstein agreed with this. And that's how he came up with the whole topic of relativity. Because relativity means you can't declare one part motionless and the other part moving, because in relativity, and everything is moving. Or if you declare that one part is motionless and the other part is moving, you must also declare that this part you said was moving could also be considered not moving, and the other part moving. That's what relativity is all about. And what did they do basically is they got rid of Newton's absolute space. And what they did is they enlarged the system now to the whole universe. Once you do that, you cannot claim that the earth must revolve around the sun, because you can put the earth in the middle as the center of mass of the universe and the universe rotating around it. And that system will be just as viable as one where you have the universe not moving and the earth having to revolve around the sun, okay? Newton agreed with this, Mach agreed with this, Einstein agreed with this. I don't know a scientist in the world today who would disagree with that summation that I just made between Newton and Copernicanism and the universal system where the universe rotates around a fixed earth, okay? So that again has been something that has been dumped on people without the other side being told to them. And that's what I'm here to do. That's what I've done in my books and my movie. I told the other side of the story. Okay.
All right. Well, Dave, I hope you took a lot of notes on that, because there was a lot to unpack there.
Yeah, there is a lot there. So, if we go back to the very first things that Bob was saying. So he's talking about, decree against Galileo. He's talking about the fathers of the church, a couple of other things like that. I don't want it to seem like I'm sidestepping that. I have lengthy articles on my site addressing all of that. I believe that I've addressed those points, really pretty comprehensively. What I would like to point out in this case is that the popes themselves have said that we are perfectly free to hold non-geocentric cosmologies. In 1820, Pius VII decreed, His Holiness has decreed, I'm quoting now, His Holiness has decreed, obstacles exist for those who sustain Copernicus's affirmation regarding the Earth's movement in the manner in which it is affirmed today, even by Catholic authors. Okay, so this is an official decree of the Catholic Church giving us permission to hold to the motion of the Earth as it is held, now according to modern cosmology. Now, Bob, I know what he's going to say if he had the opportunity. He's going to go into this big conspiracy theory as to why, that we're not bound by that and that kind of thing. But this is kind of my point, is that when you really break down geocentrism, it's this massive exercise in special pleading, and then you kind of patch it together with conspiracy theories. Now, on my site, I treat the Galileo incident in great detail. I treat the fathers of the church in great detail. Certainly they were, geocentrists. It was the best science of their day. Of course they would be. There was no reason for them not to be. But, if we talk about the fathers, Father Melchior Inkofer, Society of Jesus, who was the Jesuit that they brought in to really do the heavy lifting intellectually when they were trying Galileo, said this about the fathers. This is a quote. I have not found a single one of the Holy Fathers who has dealt with the motion of the earth clearly and positively, as the saying goes. But from some of them, it is possible to deduce a few things that seem relevant here, end quote. So, if we're just talking about the fathers of the church, and Bob will know the nomenclature I'm using here, you can't get a unanimous consensus of the fathers that's binding on Catholics out of some of them who possibly deduce a few things, but none of them who clearly and positively affirm it. So, and we find out that they made no mention of the fathers of the church in either of the decrees when we're talking about Galileo. So the church has dealt with this, and I believe it's dealt. I argue, I think I've made a contribution to the Galileo, studies here. I believe that the church actually handled this in line with her own canonical tradition in 1820 and 1822. That's my argument. Therefore, I'm going to this point, and that is that we're not compelled to go there anymore. We're not compelled to say, well, I have to hold to this whole system of special pleading and ad hoc explanations for things. I can hold to this very simple and parsimonious explanation that the Earth orbits the sun and rotates on its axis. And again, I disagree with Bob when he talks about how simple this other thing is. When you're talking about stellar parallax, okay, the whole system has to be centered on the sun, but then it has to, kind of do this wobbly thing over the course of a year that mimics, it's exactly the right amplitude, according to them, the whole motion of the entire universe, that mimics what we would expect if we were seeing stellar parallax from the Earth's orbit. But then you have stellar aberration, for example, which Bob claims can motion of the universe, and that's incorrect for three reasons. One is that the aberration observation is much larger than parallax. The second is that aberration is the observable phenomenon is the same for all celestial bodies, whereas for parallax, it varies with distance. And the third one is that it's 90 degrees out of phase with parallax. And the reason for this is that parallax is proportional to the position of the Earth, aberration is proportional to the velocity of the Earth. And we can confirm that it's actually, that aberration is caused by the motion of the observer by observing binary stars. We would expect there to be aberration there if the motion was caused by the motion of the stars, as Bob claims, but in fact, we don't see it. And so we can deduce that the motion is the motion of the observer. It's us. So he hasn't even explained stellar aberration, because the same kind of wiggle wobble of the universe won't explain both parallax and aberration. Similarly, we get into things like the equatorial bulge. This is what I call, this is leading. Bob will say, oh, well, the relativists will say that it's indifferent whether we attribute the equatorial bulge of the Earth to the Earth rotating on its axis or the whole universe going around the Earth. The is to me that, again, it's special pleading, right? Because then as soon as you cut away from general relativity, which Bob does because he doesn't believe in general relativity, he appeals to it and then he casts a cut away from it. But once you cut away from that, then you have to say, oh, well, this equatorial bulge is caused by the whole universe going around the Earth, but Mars's, Jupiter's, and these other ones, those are caused just by the normal rotating on their axis, like we observe everywhere in the universe, right? And you have this additional piece that, the ones that are spinning fast, you would expect them to have a larger bulge. Well, they do. Jupiter and Neptune have a larger bulge. The ones that are going very slowly, you expect to be small. Well, Venus does. And then the medium ones, Earth and Mars, have sort of a medium-sized bulge. All of this coheres with this simple parsimonious explanation, but it becomes this process of special pleading when you believe that you're forced by some kind of outside parameters to engage in that special pleading and the kind of asking. And what I'm asking is, if we could set aside these other things, are there observational reasons that would compel us to abandon this parsimonious explanation and take on the burden of all this ad hoc special pleading and that kind of thing?
My turn?
Yeah.
Okay. I'm really getting tired of hearing the special pleading argument, so I'm going to deal with that right now. We had Pope Paul V in 1616 and Urban VIII in 1633, who, from the Holy Office that had been assigned to deal with the Galileo case, and came back and said that heliocentrism was formally heretical and that Galileo was suspect of that, that's not special pleading, okay? That is what has been happening in the church since its inception, that a controversy arises, the church makes a decision, and that decision is followed by its parishioners. As a matter of fact, both Paul V and Urban VIII sent letters to all the papal nuncios and universities of Europe telling them what the Vatican's decision on this matter was, so that they would know what to obey and what the position of the Vatican was. That's not special pleading, okay? That's the beginning of the whole issue, and everything revolves around it. Now, David comes back and says, well, in 1820, Pius VII changed that because he said it was okay for people to believe in heliocentrism. No, that's not what Pius VII said. That's what one of his underlings said, that he tried to get approved by Pius VII, okay? Pius VII signed nothing. He just waved his hand and said, okay, do what you want. And the so-called conspiracy theory that David says I was involved in is not a conspiracy at all. The fact is that there was a man named Maurice Olivieri who was a heliocentrist, and he wanted that as the church's teaching. And he stepped on the guy who was in charge of this whole issue. His name was Father Anfossi. And he went around Father Anfossi because Father Anfossi was the only one who could make a decision in this matter. Canon Sotelli had written a book on heliocentrism, and the question was he allowed to do so? Father Anfossi said no, and he was the one in charge of giving clearances for books, the only one that can do that. So the Olivieri went around him, went to Pius VII, who was a very weak pope, and got him to wave his hand and say, yeah, whatever you want, and that's what happened. So there was something going on there, some dirty trick going on that was not in the normal process of things, okay? So it's not special pleading. This is what happened. And then he mentions Incofer, but Incofer was not an official of the church. The one that was the official was Cardinal Bellarmine. He's the one that made the decision. He's the one who has been given the power by the church to decide this matter. Inconfer can have his opinion all he wants. And there were many people in that day who had opposite opinions. But the official decision of the church was that Galileo was suspect of heresy. And you can't have a heresy unless you formally define what the heresy is, you see. Now let's go on to this so-called, wobbling that David keeps talking about. We don't have anything wobbling. We have a universe that's rotating on its central axis, and at the same time, it's going up and down. There is no wobbling. I don't know what he's talking about, okay? There are certain inertial forces that will be created in that spiral motion of the universe that may form a wobble here or there, but it doesn't mean the universe it's wobbling. I never said that, never taught that. He said—
ask you there, what about for like nutation and precession? How would you get those? Nutation and precession. What we would call the polar wobble.
That is natural to any moving object. Okay, if that's what you're calling wobbling and you're waving your hands as if this is some kind of trick that's being used, no. Nutation, precession are common occurrences of anything that's rotating. Okay, so I mean, you're trying to make it sound like I need this abracadabra wobbling universe to do these tricks so I can get everything to coordinate in its movement. That's certainly not true. You're the one who's special pleading here. Now, you went on to aberration. You say aberration can't be used. Yes, it can. Your three reasons why it couldn't be used: that it's larger than parallax. So what? I mean, if the star system is moving in a certain way, it's going to form a circle at the top, an ellipse on 45-degree angle, and a hyperbole at the equator. That's what's going to happen, and we have diagrams that show that. So I don't know what you're talking about here about because it's larger. Doesn't make any difference whether it's smaller or larger. You had another second disagreement about that. I forget, I put down yes, all, I don't know. Maybe you want to explain that again? What was the second reason you didn't believe that geocentric stellar aberration was viable?
Oh, yeah, the three were, and again, what I'm saying here, Bob, is that you have the universe doing one thing to explain parallax, and then, but you're applying the exact same motion to aberration, it won't work. And the three reasons are because the observable phenomena of aberration is larger than parallax. It's the same for all celestial bodies, that stars and galaxies are it has the same observable phenomena for aberration, whereas parallax varies with distance to the object, and it's exactly 90 degrees out of phase with parallax. So the same universe
when did I ever disagree with that? I write the three things you just mentioned, I write in my book as necessary for stellar aberration. Your job is to prove why those three things can't be explained from a geocentric framework.
Is that an invitation?
Of course it is.
Yeah. So we're getting back to what we're saying here, and that is that again, what I'm trying to point out is that Bob has to attribute all these things to the entire kind of rock and roll shilly-shally of the universe, and that is special pleading because all these other bodies that we observe, and this was your argument to the flat earthers, right? You could plug flat earth into this thing. You basically said, everywhere we look, we see round bodies, right? Every celestial body we see in the universe is round, right? Well, yeah, but they all also revolve on their axis and rotate on their axis, and they orbit the ones that are less massive orbit the more.
Let me interrupt you here.
So basically, you're saying is this is the grand exception, and in order to argue for that, you have to have not only all this motion of the whole universe. This is like a gigantic universe, and you also then have to have. We'll get to this, I think, two forms of ether to fill in the gaps.
No, you're wrong there too. Let me go back to the aberration. Okay, you keep going with the shilly-shally rock and roll kind of universe that I believe in, and you got it wrong, okay? The universe I just told you was one that rotates on its central axis and goes up and down to take care of the seasons. That's it, okay? So there's no shilly-shally here. What your job to do, Dave, is to show us that system, it cannot work to explain any of the movements we see out there. That's what your job is. Your job is not to tell the people that, well, because it's a shilly-shally, somehow it's complicated, and when we want to be parsimonious and stick to Occam's razor, well, that's the reason we have to we have to reject the shilly-shally, and we'll just go with what I believe is the simple system, and that's the Earth going around the sun, as if you have a simple system. You don't. So you're not going down the right path here. You tell us why a universe going around a fixed Earth, first of all, can't happen, and second of all, why it won't show these movements in the sky.
So here's what I would say. I don't subscribe to the position that a particular scientific theory can be proven to be true. I don't hold that, okay? But I don't think then that all of a sudden makes explanations equally reasonable. And you, I think, acknowledge this when you're talking to the flat earthers. They have explanations too, Bob. If you talk about, oh, you observe, the stars going different directions on the poles, they can put these two disco-like domes out in the universe and reflect the light back in just such a way. And you say, well, that's preposterous, but they would say, yeah, but I have an explanation. Prove to me that it can't work that way. And so what I'm saying that there are parsimonious and harmonious and simple explanations. The simple one is that the Earth orbits the sun and rotates on its axis like every observer. And yours is that this is the only exception to this, right? And to get to the special pleading point, I laid one out for you, the equatorial bulge. I don't see how you can call that anything other than special pleading. You have to say, this equatorial bulge is caused by the whole universe going around the Earth, but those other equatorial bulges are caused by just the normal mechanism of the planet rotating on its axis.
Yeah,
that's
not special pleading, because it works. If you put the Earth in the center and you have the universe going around it, there will be a bulge. I mean, Mach himself, Einstein said this. I'm not the one who originally said it. And in that very system that Einstein agrees with, a rotating universe going around a fixed Earth that will create a bulge, he said also that the planets have their rotation outside of the center of mass of the universe, which is the Earth, and they will have a bulge too. So you're trying to make something complicated that can be explained from either system, okay? What's your job, I believe, is to show us why the geocentric system can't work. Not to tell us, well, you have this universe doing all this kind of stuff over here and the planets are doing their stuff, and that just sounds weird to me, and so I can't accept it. That's not science, Dave. Science is when you can prove to us that the system doesn't work, not whether you can shilly-shally here and tell us that because the universe dances somehow that doesn't, come up to snuff in science.
Right. I mean, we get into this other thing though, and that is that you require these two ethers to explain these various phenomena as well. So you have to introduce those. I'm surprised you haven't gotten there yet, but basically what I'm saying.
What does that prove, Dave?
I'm sorry.
Even if you were correct, what does that prove?
What it proves is that you're adding in a lot of additional things to explain your system that aren't necessary to explain the phenomena, right? So really, again, I'll go back to this thing. I don't think there's any compelling reason to abandon this simple explanation that the Earth orbits around the sun, rotates on its axis. I don't think there's any compelling reason to abandon that for this other system that requires this whole universal motion. It requires the special pleading about the equatorial bulges. It requires two ethers to explain it. You've got ether winds blowing around to try to explain different phenomena.
I don't have.
It's not reasonable to abandon the universally observable phenomena for something that you just have to kind of patch together like that.
Yeah. First of all, I don't have any ethers blowing around. Okay, let's get that clear. And if you want to talk about ether, the very one that put the ether back into modern science was Albert Einstein in 1920, because he found out that things just wouldn't work well in general relativity without his ether. And Steve, I sent you that stuff from my book that talks about that very subject. I hope you read the quote from Einstein himself that said we have to reintroduce the ether. Okay, so here's the greatest scientist we've ever known introducing ether, and yet you're complaining to me that if I have two ethers, which I don't, okay, that somehow this system is just too complicated because I got ethers and I got a shimmy shammy universe and all this stuff. You still haven't proven anything. Okay, as a matter of fact, Einstein, in 1887, in order to explain the Michelson-Morley experiment that showed the Earth wasn't moving in space, he decided that the only way he could explain that was to do away with the ether. That was in 1905. And then 10 years later, in 1915, he found out that it couldn't work that way, that he needed his ether. And so he gave a speech in Leiden, Holland, and said, yeah, we need to take the ether back. Okay, so here you have a total contradiction in modern science between what was said before and what is said now. And I think it's quite telling that in 1905, this special theory of relativity was invented in order to have some kind of answer to counter what Michelson found. And what he found was that the Earth wasn't moving in space. Okay, and then when Einstein comes along in general relativity in 1915, he himself says, yeah, well, it's true. You can either have a universe rotating around a fixed Earth, or you can have an Earth rotating in a fixed universe. Either one can be true. Now, you're claiming that because I cite Einstein, that somehow because I don't believe in Einstein, I can't use him as an authority to what modern science itself believes. Okay, that's false, Dave. That's what I call special pleading. You can't do that. I'm not saying I agree with, I'm just saying that he's in a fix. His modern science doesn't work because he's got two contradictory theories. The one that does work is the one that we find where the Earth is in the center and we have a universe rotating around it, and it's very simple. We basically have one moving part that takes care of everything else in the universe. How simple can it be? And our universe is so massive that the mere inertia of a rotating universe is going to be enough to compensate for any inertial force, any gravity, any volcano, anything that happens out there is going to continue to go the same rate, the same sidereal rate. But the Earth, according to all the things that have happened, should have stopped rotating a long time ago from all the inertial forces that are out there. So again, you have the complicated system and you're the one doing the special pleading.
Okay, well, thanks. So I just wanted to touch on a couple of things that you said, Bob. One of them is that you said that you don't have ether winds blowing around. I do want to talk about the Michelson-Morley experiment, if you're game for that, because I know that that's a really important part. I thought you were going to go there.
I'm not game, Dave.
I thought you were going to go there earlier, but we're there now, so I think that's worthwhile. But you do say, and Galileo was wrong. It's first volume, page 168. It's the same ether that caused the 1925 Michelson-Gale experiment to experience an ether drift is the same ether that causes the Foucault pendulum at the North Pole to rotate. So you do have ether winds blowing around, right?
Yeah, but I don't have two of them, Dave. That's what I said to you.
How about this one? This is on page 207. You say the ether is composed of at least two substances, one at the Planck scale and the other at the atomic scale. And then you go into what the second type of ether is. It's on the atomic scale. You talk about this electron or positron pairs, what you call it electron ether, right? They said it is these ethers, in the plural, Bob, which serve as the media for all motion, inertial forces, gravity, and electromagnetism. This is page 207 of Galileo Was Wrong, volume 1. You do have two ethers.
No, you said
and the one that I want to make it clear too, the one that Einstein eliminated was that luminiferous ether, which I think is equivalent to your electron ether. He made it and it stayed eliminated. And it was eliminated because they refined the interferometer experiments like Michelson-Morley, and they keep finding that there's no evidence for the luminiferous, or what you would call the electron ether.
No, that is false, Dave. And it shows you haven't really studied the issue. They did find the ether. They just didn't find enough for an Earth rotating around the sun. Every experiment that was done from 1881 through 1930, JOOS being the last one, JOOS, all found a residual amount of ether, around 10% of what they expected, every one of the experiments. But what they needed was an ether that was commensurate with 30 kilometers per second, which was the proposed speed of the Earth around the sun, which they never found. Okay, that's the issue here. They all found ether, they just didn't find enough for the Earth going around the sun. Now, since we're on this topic, let me go to the Michelson-Gale experiment in 1925. This one, instead of measuring the Earth's supposed speed around the sun, was supposed to measure the Earth's rotation on its axis. And you know what they found there? And they used the same equipment that Michelson used in 1887, the interferometer that measures ether. What they found there was almost 100% of the ether drift required for a relative rotation between Earth and space. Okay, so there you have the ether again. That's why I mentioned ether in the book. The only ether I have in the book is the one that rotates with the universe around a fixed Earth. That's the only one. So you're waving your hands, I have ether going here and there. That's not true. There's one ether that travels with the universe, the very ether that Einstein himself approved of. That was the result of the Michelson-Gale experiment, which showed 100% relative rotation. But when they tried for the revolution of the Earth around the sun in 1887, there wasn't enough. There wasn't even a quarter of the ether that they needed. So what does this tell us? That the Earth isn't revolving around the sun, but there is a relative rotation between the Earth and space, exactly on the sidereal rate of 23 hours, 56 minutes, and 4.1 seconds.
Okay, so I would really like to go into the Michelson-Morley experiment some more, because I do think you're missing some things here, Bob.
Well, what are they, Dave?
Let me bring them up. Okay, so this is going to take a little while to unpack, but I definitely want you to interact with what I have to say here. So, I'm not going to just hog this, but it's going to take a little while to unpack. So, first of all, why don't you just go ahead and tell us about the Michelson-Morley experiment in terms of how it's set up and how it actually works.
Dave, I don't really.
What we're trying to measure and how.
I just told you what the results were. They were looking for ether drift commensurate with 30 kilometers per second. They only got about 5 kilometers per second. That was the residual I talked about, that every interferometer experiment for the next 50 years also found 5 kilometers per second plus or minus 1 or 2 or 3. That's what they found. They didn't find enough for a revolving Earth around the sun, which was required if you could get 30 kilometers per second. That's all we need to know about that experiment.
So let me ask you this. Would you agree that subsequent interferometer experiments have driven that upper bound of 5 kilometers per second down to incredibly low levels? My colleague Alec McAndrew calls it insane levels of precision here. So it's actually that upper bound of the invariance of the speed of light from modern interferometers is down around 0.3 nanometers per second, right? That's instead of that 5 kilometers per second you're talking about, which is an upper bound, by the way. Wouldn't you agree that modern interferometers have driven that number in terms of what they measure, the possible variance of the speed of light, way down, so far down that they are not measuring luminiferous ether?
First of all, that's not going to help you, because the lower they get it, if these things are legit, the more you have just dug your grave, because you believe the Earth's going around the sun. So if you're getting even a smidgen of an ether resistance, why aren't you getting an ether resistance that's commensurate with the Earth going around the sun? You're nowhere near it. So that even digs your hole further. The second thing is this. If you encase an interferometer in a vacuum chamber, then you're just eliminating the possibility of it detecting the ether. Okay? We don't know what the ether is.
Why is that? Why would you be eliminating that?
Because you made a vacuum. There's nothing in a vacuum that can be detected. There's no material substance there. But the ether is a material substance. And that's why every ether experiment that showed 5 kilometers per second was one that allowed the apparatus to be above ground, not 10 meters below ground where it couldn't be hit by anything. You have to give it the space that it needs in order for it to detect this ether. So the question to you basically is, why did they detect 100% of the needed ether for a rotation, but couldn't detect the needed ether for a revolution of the Earth around the sun? Explain that to me.
Sure, I have a couple. I absolutely can, actually. So did you realize that the Michelson-Gale experiment was done with vacuum in the path?
Yes.
So then you just said that pulling a vacuum pulls out the ether. Why then would the Michelson-Gale experiment
show? Because they have it encased many feet below the ground in a vacuum in order not to let anything impinge on this so-called interferometer. Michelson-Gale did it above board, if you've seen the pictures. And that's where all these experiments have to be done, on the surface of the Earth, so that this ether has an easy time affecting the experiment. And it did. It measured the ether. That's the fact. That's the fact you have to deal with.
Well, actually, what is happening here, actually, Bob, is you just acknowledged that the modern interferometers are driving this number down, 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 down. That's commensurate with an actual null, which means that there is no ether to detect, right? We're talking about an upper bound here, right? It's not that they detect the 5 kilometers per second. That's the upper bound of what they could detect within the precision. But as that number gets smaller and smaller and smaller, it makes it less and less and less likely that there could be any luminiferous ether. But what I'm trying to say is that if you're saying that there's no ether in a vacuum, then these interferometers, like the Michelson-Gale, shouldn't have been able to detect it at all, right?
No, I'm not saying that. I'm saying your vacuum interferometer is like 10, 20 feet below ground.
They're not all that way.
Huh?
They're not all that way.
Well, okay.
If, for example, the Sagnac effect, which you say is the best detector of the ether, the Sagnac effect is observed in vacuum in the light path. It's observed with gas in the light path. It's observed with solids in the light path. It's observed even with liquids in the light path. So the Sagnac effect shows up in all of these instances, and you're saying that it shouldn't, that only in certain of those instances should it even show up at all.
That's not what I'm saying, because I attribute the Sagnac effect to the Coriolis force. And that's why
via the ether, right? It's still detected, but via the ether, correct? The luminiferous ether.
No, the Coriolis force, whatever it is, it's going to make in the north, it's going to make the light wave go one way, and in the south, it goes the other way. That's an established fact. So you're saying it's the ether, but what's controlling the ether? That's what we have to look at here. That's why I said to you that if you get 100% result in the Michelson-Gale experiment, when you're actually looking for ether, the ether has been found. Okay, you're trying to combat that by saying, well, this interferometer that's built underground and is in a super vacuum and doesn't detect the same amount that's in the Michelson-Gale, that's not going to do it for you, Dave, because the Michelson-Gale experiment did measure the ether moving against the apparatus. That is the fact.
So let me just address a couple of those points. You say that the Michelson-Morley experiment got a 5 kilometer per second ether drift?
Yes, about that.
So wouldn't your own model predict an ether drift of only 0.46 kilometers per second at the equator and 0.38 kilometers per second at Mount Wilson? That would be the whole ether going around the Earth. Where's the extra ether drift coming from?
You're getting the two experiments mixed up.
No, I'm talking about Michelson-Morley.
Yeah, Michelson-Morley did not have what'd you say, 0.465?
Yeah, 0.46. You're saying it got 5 kilometers per second of ether drift. Where did that come from?
You're using the wrong figure, Dave.
You told me that it was 5 kilometers per second that it registered of ether drift, and I'm asking you, where did that come from?
I explained this in my book. I'm surprised you haven't read it. Because if the Michelson-Gale experiment measured 100% of the ether required, and it was orthogonal to the position of the Michelson-Morley interferometer, then invariably you're going to get some of the ether that was detected in the Michelson-Gale to cross right over the face of that interferometer, and it's going to be detected by that interferometer. But it's only going to detect a little bit because it's orthogonal to the direction of the ether. Okay? That's why they only got 1, 2, 3, 4, 5, because that's where it's coming from. And we would expect that. If the universe and its ether is rotating around a fixed Earth, some of it's going to get into the Michelson-Morley experiment in 1887.
So I think this contradicts what you said earlier, that you don't have ether winds sort of blowing around. You do.
You don't have what?
That you don't have ether winds blowing around. I think you do. I think you do have them blowing around.
Dave, I just clarified that for you. I said the only ether we have is the one that's rotating with the universe. That's what I said. That's why Michelson-Gale picked up 100% of the ether.
Yeah, because the thing is that is only 0.38 kilometers per second, the one that's rotating with the universe at Mount Wilson.
And that's what they detected.
No, they detect. You just said they detected 5.
No, that's the Michelson-Morley experiment. I told you, you got these confused. Look, let me say it again. Michelson-Morley, they needed 30 kilometers per second for a revolving Earth around the sun. They only got about 5. The question was, what do we do with it? Well, we'll just chalk it up to experimental error. And that's what they did for 50 years. They still had this 5-kilometer residual ether drift measured in the Michelson-Morley experiment, okay? Let's lay that aside for the time being. Then you come to Michelson-Gale, and they do a measurement of the ether drift with rotation instead of revolution. They find 100% of the ether that they need to verify that there is a rotation between Earth and the universe. Okay, 2 different experiments.
Okay, all right. Let's touch on a couple more points here. Let's go to that point that you say that they actually got a positive result. The fact of the matter is that if you look at a 2006 article by Dr. Thomas Roberts, it's called An Explanation of Dayton Miller's Anomalous Ether Drift Result. Dr. Roberts does a detailed statistical error analysis on Miller's work, which came after Michelson-Morley, but for which we have the whole data set. And he summarizes his findings thusly. Posthumously, Miller is now experiencing every experimenter's nightmare. The standard analysis algorithm used by himself and all his contemporaries had serious flaws, not explicable for many decades, and they caused the noise in the apparatus to perfectly mimic the signature of a real signal. He applies the same statistical analysis tools to Michelson-Morley, also Illingsworth, and he finds that there was not actually a valid signal in their data. They thought there was a positive result, but there's not. Now, here's the point that I'm trying to make, Bob. Subsequent interferometers, which aren't all buried down below the Earth, you're making that up, okay? There are different kinds. Some have vacuum in the path. Some have sapphire, right? They're these whispering gallery resonators, right? They are not detecting. Their precision is getting better and better. And so the upper bound of what the invariance of the speed of light could possibly be is being driven down and down and down and down, increasing our confidence that there is no luminiferous ether. So the initial results of the Michelson-Morley and the Miller experiments were invalid, and subsequent interferometer experiments are showing us that there is no luminiferous ether, and the speed of light is in fact invariant to the extent that we can measure that, and that alone explains the Michelson-Morley without any kind of positive of an immobile.
Let me tell you why it doesn't. You know why? Because they assume a Lorentz transform occurred in the sapphire oscillator that they're using. You know where the Lorentz transform comes from?
Actually, that's not true, Bob. That's something that you use, and it's rhetorically very effective. But let me back up. When they were talking about the results of the Michelson-Morley experiment, it's certainly true that Lorentz proposed that there was the contraction of the apparatus itself, right? That was actually widely criticized at the time as being sort of an ad hoc explanation. But that's not the explanation of the Michelson-Morley experiment that eventually triumphed. It was Einstein's second postulate that the speed of light is invariant. And if you have gotten this evidence for no luminiferous ether that's impeding the light beam, and you're getting increasingly precise evidence of the invariance of the speed of light, that's all that's necessary to explain Michelson-Morley. You don't have to use the Lorentz contraction to explain it.
Yeah, well, the fact is that they do.
No,
they did.
They don't.
Oh, yes, they do.
Lorentz did. Lorentz proposed that, but it's not necessary. All you need is the invariance of the speed of light to explain Michelson-Morley. That's all.
No, but
it's rhetorically effective for you because it was sort of an ad hoc explanation.
No, it's not rhetorically effective for me, Dave. Okay, the way it stands is, if you're going to say the speed of light is constant, you can't have an ether. Okay, but they always got this residual effect of an ether, whether it was Lorentz or Einstein. And then Einstein comes along 15 years later and tells us that there is an ether. You're aware of that, right?
He wasn't talking about a luminiferous ether. He did not hold that. And so I'm going to go back to this now. I'm going to go back.
He did, because he said light has to travel through that ether in order from get to point A to point B. That's what the paragraph says.
So the point that I'm making here, I'm just going to make it again, is that the statistical analysis of those early experiments showed that they had flaws that caused them to think they were seeing a positive signal where there wasn't a positive signal. Subsequent interferometer experiments are getting our confidence in the invariance of the speed of light, driving that down and down and down and down in terms of precision of the instruments, to the point where you holding that there's a luminiferous ether out there that they just aren't detecting is untenable. It's experimentally, observationally untenable, because the instruments are getting more and more precise. They should be detecting this thing that you say is there, and they don't.
No, and I'll maintain my point, Dave, is you can't detect it if you cover the interferometer. That's why the interferometers that were used that did detect it were open above board on the ground so that they could detect the ether. That's the same reason the GPS detects the ether, because it's open. It's right there in space, so that the universe that's going around it, or whatever you think the ether comes from, it's going to hit it. Okay, and just because this somebody came out with a paper in 2006 that says, well, he did an algorithm and found out that they didn't really have a signal. You know how many papers like that are out there? Okay, there's everybody trying to figure out how they can prove that the Earth moves, but nobody has the experimental evidence to show that it does move. Whether you're talking about a Sapphire oscillator or Michelson-Morley or whatever you want to talk about, that's my question to you. What do you have as proof that the Earth moves?
I said early on that I don't think that scientific theories can be proved the same way that you can prove a mathematical theorem. But
but you're willing to write that geocentrism is just. You're willing to write that geocentrism.
You guys are talking over each other now. So
kind of theory.
Robert, you guys are talking over each other a little bit. So
all right, let me make this point because it's very important.
Make the point. Then roll back to Dave.
Dave just told us that he has no proof that the Earth moves, that he doesn't think it's even possible to prove, and yet he, in his writing, says that geocentrism is impossible, and but scientifically he doesn't know that because he has no proof. Even his own oscillator that he said doesn't show an ether drift is enough proof for him that nothing's moving. Okay, and so again, we're back to square one. What does Dave have to prove that geocentrism is scientifically not viable and is full of errors? What does he have? What proof?
So I want to go back to this matter. You just said that if you had this instrument totally shielded, you wouldn't be able to detect the ether, but it's just a fact that ring lasers buried deep underground are able to measure the rotation of the Earth. Now, which is it? Is it that they're doing that via the ether, or?
Wait a minute, Dave. You just said you can't prove that the Earth moves, and now you're telling me that the ring laser.
What I'm asking you is very specifically to back up your claim that if you shield an interferometer, that it can't detect the ether. Ring lasers buried under the ground, deep underground, can in fact detect the rotation of the Earth. How would they do that, Bob?
Well, because you don't know what's the rotation of the Earth, Dave.
But I'm asking you, does the ether penetrate there or not? Can that? How, if they're not detecting it via the ether, how are they doing it?
It's not a vacuum chamber that the ring laser is put in, as far as I know.
The path that the beam is going through is certainly a vacuum chamber.
Well, then what I would say then is
these are buried 30 feet underground. You just said that should shield the ether, but they can still detect this. How is that?
Yeah, because the Coriolis force is not the same thing as ether. I said, when you brought up the Sagnac effect, I said, yes, it's because of the Coriolis force. And that's why the Sagnac beam goes in different directions in the northern hemisphere as opposed to the southern hemisphere. So you're mixing the force with ether.
I understand you correctly, though. You're saying that it's detecting it via the ether. That's what I'm understanding you to say.
I don't know that. All I know is they detected ether when they did the experiment in 1925 for the rotation between Earth and space. I do know that the Sagnac effect occurs and it has different motions in the north and the south. Whether the Coriolis force affects the ether, who knows? All I know is what the evidence tells me. But you said a ring laser shows the Earth is rotating. No, it doesn't. All it shows is a relative rotation between space and the Earth.
Of what? Relative rotation of what? Of ether?
Of the universe going around a fixed Earth.
No, Bob, what is it detecting?
It's a force. It's called the Coriolis force. That's what makes the hurricanes go counterclockwise in the north and clockwise in the south. That's what makes the Foucault pendulum. If we want to make a supposition that the Coriolis force is actually the ether that's moved by the universe, fine, I'll go there. Okay, but the point is that we're finding the ether, and we found it in these experiments. And algorithms are not going to do it for you. They're not going to whisk away the fact that we got this huge disparity in Michelson-Morley's experiment as opposed to Michelson-Gale's experiment. Where does that disparity come from, Dave?
Yeah, actually, I would argue that there is no disparity between the two because, as I explained earlier, Michelson-Morley and then Miller thought they were seeing a positive signal, and they weren't. But Michelson-Gale does, in fact, pick up the rotation of the Earth through the Sagnac effect.
Now, you still have a problem, Dave, because they picked up 5 kilometers in the Michelson-Morley, but they picked up the exact amount of kilometers per second they needed for the Michelson-Gale. That's a big disparity. That's a disparity of 90%.
Well, Bob, I think
you're telling me that there are no signals.
I think you're not hearing me when I'm saying that Dr. Roberts demonstrated that Michelson-Morley and Miller thought they were seeing a positive signal, but they were not seeing a positive signal. Dr.
Roberts did not demonstrate that. He found another way to explain what he thinks Michelson-Gale saw and what Michelson-Morley saw. And there's a lot of people out there who try to explain different ways of looking at this, and that's what science does. I have no problem with that, but that doesn't mean he's right, Dave. Okay?
I think that what we're kind of getting into now is a little bit of that conspiracy stuff. So what I'm saying, though, what I really want to focus on is that one of your major arguments has been with the Michelson-Morley experiment and, it detects this ether. But the fact of the matter is that more modern interferometers are not detecting the luminiferous ether.
Yeah, but we don't know exactly why. And even
your use of the Michelson-Morley experiment is invalid because you're basically saying, oh, well, this proves that there's this luminiferous ether, but there's not enough of it so I can still hold that the Earth is motionless. But the fact of the matter is the argument's invalid because what the observational evidence is showing more and more clearly is the invariance of the speed of light, and therefore there is no luminiferous ether to impede these light beams.
Yeah, and I told you before, they use the Lorentz transform in order to explain the sapphire oscillator experiments. I know because I read the literature, Dave. And if you start out with the fact that the ether is going to be affected by a Lorentz transform, you've already sullied the experiment. And the reason they do that is because they think that the Lorentz transform is a scientific fact. Why do they believe that? Because they didn't see the Earth moving in the Michelson-Morley experiment, and so they had to invent the Lorentz transform to keep the Earth moving.
And
Are you saying that the Lorentz transform isn't used today, Dave?
Now, I'm not saying it's not used, but I'm saying it doesn't have to be used to explain the results of these interferometers.
But it does. Go read the literature and find out that they do use the Lorentz transform in the oscillator experiments.
Yeah, you certainly wouldn't have to in the Michelson-Morley experiment, and there are modern Michelson-Morley interferometers, and you don't have to use a Lorentz, for that.
Sure, Dave. If you get a 5 kilometer
luminiferous ether, it doesn't exist.
If you get a 5 kilometer result and you're looking for a 30 kilometer result, the only way to get there is to use the Lorentz transform.
No, actually, what you can do is analyze the data and understand that he thought he saw a positive signal and he wasn't actually seeing a positive signal.
Yeah, well, you can propose that.
What experiments have demonstrated to a greater and greater level of precision.
Yeah,
so I think you're denying the observational evidence. You're denying the experimental evidence.
No, because I know all about science, Dave. I know when somebody says something, it doesn't mean it's gospel truth. Okay? That experiment at Michelson-Morley was repeated dozens and dozens of times over 50 years, and they all got the same result. And you're telling us it's just a mirage.
They actually didn't get the same result. So what I want to do is just, I think maybe we've exhausted this one, I don't know, but I would refer everybody to Thomas Roberts' article, An Explanation of Dayton Miller's Anomalous Ether Drift Result. You'll see a very, very robust statistical analysis of the original data there.
Well, this is a good time, I think, to open it for questions that we might get from the audience, read off a couple of super chats, and then wrap it up, because it has been close to an hour and a half, so that's That's good.
Yeah, let
That's
me
too bad. I had a couple of really good questions to ask Bob, but go ahead.
let me read some super chats. Maybe get a couple questions of my own that I want to ask both you guys out of the way. Then, if you want to continue on it, I'm in no hurry to be done with this. This is fascinating, but we have to read the super chats. So let me get them out of the way. First super chat was Fostering Atheism says, can't stay for the show. It's my son's birthday, but wanted to show support real quick. Thank you, Fostering Atheism. We do appreciate your support, and happy birthday to your son. 0132 can Sungenis demonstrate a difference between Earth and Proxima Centauri b being the immovable center of the universe? If you want to hold off on that, my question is kind of similar. You want to
All right, go ahead.
Okay. Jake says, this is my book money for Steve. Stacks of books in the background, adds 25 IQ points, and adds more credibility than a PhD. I have books here, believe it or not, and people have been sending me books.
They're not visible.
Dude, look what I'm reading now. This is my book that I'm reading now. See, Leonard Susskind. I do read, believe it or not. I know people don't believe that. Insane Dragon says, Inane Dragon. I'm sorry. You're not insane. Sorry, I'm sorry.
Wow.
I like Inane. He's a good guy. Can you explain why we compensate for relativity in GPS if Aether is true? That goes to my question as well. And he also says it's time for a shot color for Steve because they can see my frustration on this. Okay, so let me ask you guys some questions here. This is the problem I'm having. And again, it's been many years since I've had physics and many years I've had these topics. So bear with me if my vernacular is not up to speed compared to you, because both of you gentlemen have been doing this for a long time. But the way I understand it, with special relativity, it doesn't disprove Aether theories, but it just doesn't need them. And when you have an Aether theory, there's a difference between a luciferous Aether theory and then something like Einstein's Aether theory. Einstein's Aether theory uses a metric space, but as the way I understand it, he's just using a vector field as an Aether rather than some kind of actual medium. And the difference being is that in special relativity, these hold to what's called Lorentz covariance, meaning that they have, what you said, the Lorentz transformations, that everything will basically be able to be transformed from any non-preferred frame of reference. And with the Einstein Aether theory, that loses that, correct? It's local, it's Lorentz invariant, and you do have a preferred frame of reference. Is that correct, as far as I'm understanding it?
Well, no, I mean, in special relativity, you're supposed to have an inertial frame. And only in an inertial frame.
But you have no preferred, correct?
No preferred, yeah.
Okay, so my question is, if that's the case, and you could do a Lorentz transformation for any place you want it, and people that don't know, they're just a fancy type of a Galilean transformation. And a Galilean transformation is you kind of take an X, Y, and you move them around an axis. And then when you're moving towards the speed of light, that has a major effect because of time dilation and Lorentz contraction. So you use Lorentz transformations. Is that correct, Dave? Something along those lines?
Yeah, right.
Okay. All right. So my question to you is, if you can make any place in the universe your preferred frame of reference, if you're not using special relativity, you want to use some kind of Aether theory, what does prevent somebody from not just using the Earth as a center, but as Jupiter or some other galaxy? And as you pointed out, by the way, Dave, no scientific theory has ever been proven because they're non-provable. You don't ever prove a scientific theory. In the history of mankind, no science has ever proven one. So to say that he can't prove a scientific theory is a little bit rhetorical because no science ever does. We don't prove scientific theories. We demonstrate them. But we do subscribe to the law of parsimony or Occam's razor. So the question is, why would I take Earth to be the center of the universe when I can do the same transforms to any place in the universe?
Oh, very easy, Steve. I mean, that's why Dave and I went through this whole thing about what the church said to Galileo, what the fathers said. Somebody has to be the authority here, because if scripture says that the earth doesn't move, that's our foundation. That's where we start from. Okay. So it really makes no difference whether mathematically you can make Jupiter the center of the universe. I agree with that. The question is, where are we going to go now that we have two choices or three choices or four choices? Well, we go right back to the authority that gave us all this, which was the church. And that's why Dave and I have a special frequency here we can work on, because we do both look at the church as our authority. We look at the Bible as our authority. Somebody has to be at the end of the road here to give us the right direction to go into.
Okay.
So can I jump in here?
Yes, please. I'm so glad that he said that.
On the exact same thing, though, Bob. Okay, so he wouldn't accept that, right? He wouldn't accept that as a reason. So are there observational reasons that you would give him to hold that this one is the one that you should take as the absolute?
Yeah,
right?
There's a lot of
general relativity and special relativity and take this as the absolute side.
yeah, and that's what my books do. Basically, I admit that science really can't prove anything, but I say we have substantial evidence. If you look out into the sky with special telescopes, you can see this evidence. Let me give you an example. I think I used this on the last program. Hubble's looking through his telescope in 1929, and he sees all the galaxies out there, north, south, east, and west, and he sees that they all have a redshift. Okay? So the question is, wow, what does that do? Because if he doesn't see blue shift in the same, in another region of the sky, but he just sees redshift all around him, his conclusion was that we have to be in the center of the universe. Otherwise, we would not see redshift everywhere we look. We would see blue shift. Stephen Hawking sees the same thing. He admits it in his book, The Brief History of Time. He says, it may appear that we are in the center of the universe. So how do we get out of this, is his question. And Hubble said the same thing. How do we get out of this? Because we believe that the Earth can't be in the center, and we don't like that. I understand why they don't like it, because if you put the Earth in the center, that changes things.
But
that means we're not here by time and chance. Somebody designed the Earth to be right in the center and have everything else revolve around it. So what did Hubble do? Hubble decided to, well, I'm going to invent the balloon universe. I'm going to take away the center. I'm going to put everything on the balloon and have it expand. And if it expands, then everybody's going to see a redshift on the surface of that balloon. Okay? That's what I would give this guy as evidence.
All right, well, let me ask Dave. Dave, I mean, if I went to a neighboring galaxy, let's say I was in Andromeda right now and I was on a planet there, would I not have the same observations that I'm having here? I mean, they would also be using the same argument that he's using from their perspective, would they not?
Yeah, quite likely they would. And I guess this is part of the problem that I have, is that they would be seeing the same kind of, their planets would be rotating on their axes too, right? Their planets would be going around, their stars. And I think, again, it observationally, even if we take, certain cosmic phenomena, I happen to think that Bob, for example, is misinterpreting certain phenomena from the cosmic microwave background. Mm-hmm. But that's at a cosmic scale, right? I'm still focusing on the things that we can measure most closely and observe most closely.
Look, I was asked.
You still have a big.
Hold on 1 second, Robert. Let him finish.
When you both talk, nobody can hear either one of you because
I just think that it's on this local scale in particular where you don't need to invoke this whole swirling universe to explain things like parallax, aberration, equatorial bulge. There's no need to invoke it. Right? It's superfluous. We launch spacecraft, the Pioneer spacecraft are out beyond, our solar system. They didn't detect, any acceleration going from zero with respect to the ether to all of a sudden going beyond hyperlight speeds with their accelerometers. There's no, and scientists and engineers don't factor in the whole rest of the universe when they do those kind of orbital mechanics. There's no need to posit this. And that's why I say it's unreasonable to take the parsimonious explanation of these things that we can observe and measure most closely and blow out into all these other explanations.
Yeah, actually, Dave, you know what frame they use? They use the Earth-centered inertial frame. That's a fixed Earth to send out their probes and satellites.
But why wouldn't they have gotten these accelerations that we would expect for them to accelerate to hyperlight speed? Once they're out beyond
I don't know what you're talking about, Dave.
So if the whole universe.
Hold on, David.
To send up satellites and probes, they use the Earth-centered inertial frame instead of the solar barycentric frame, because a solar barycentric frame is too complicated. Okay, so if you want to talk about Occam's razor, they use a fixed Earth as their source point for sending out these satellites. Okay, and you're giving this whole thing about, well, we don't need to have another explanation because the heliocentric system works. That's not science, Dave. That's anti-science. What you're basically saying is we don't want another explanation. We just want to stick with this explanation and we'll assume it's correct, even though when I look out in space, I see redshift everywhere and I shouldn't be if I'm not in the center of the universe. And your thing that you just said about, well, if I was out here in another galaxy, I'm going to see the same redshift. Okay, that's not true. As a matter of fact, that's the whole reason Hubble answered the question this way, because he said, if I'm out there on the outskirts of the universe, I'm going to see blue shifts and red shifts. But he only saw red shifts. And he interpreted that as being in the center of the universe.
What do you mean on the outskirts? On the observable event horizon?
Something other than the center.
Okay. So I have one other question.
Time for one more question, or
yeah, you do.
Yeah. Let me ask one more here. This concerns a very long baseline interferometry, Bob. Familiar with that, where you take radio telescopes that are actually, physically separated by a long distance, hopefully on other sides of the Earth from each other, and they look at objects, and then their data are synchronized, right? You deal with this in your book, but you say about the VLBI, the only way NASA or JPL could distinguish between the two, that is, either the Earth is moving or the radio source itself is moving, is for them to allow the VLBI to absorb radiations from at least 3 sources, if not more. If it is found that all the other sources are moving in the same precise way as the original source, then there is evidence that the Earth is rotating. That's end quote. That's from your book. Now, here's another source. Usually, the VLBI data are acquired over a 24-hour period on about 30 quasars in about 30 different directions. By observing many sources distributed across the sky with multiple antennas distributed around the globe, one can simultaneously solve for the source positions and the orientation of the Earth in space. So with VLBI technology, they can detect variations on the Earth rotation from tides, from precession, from nutation, the influence of the moon, suns, and planets' gravitational torque. They can even detect tectonic plate drift, okay? By your own admission, this is evidence for the Earth's rotation, because they do in fact look at multiple sources. And it seems to me that then, on what possible reason would we have to hold that all of these quasars, these vastly different quasars, it is they that are moving in exactly the ways that would mimic things like tidal shifts on the Earth's rotation, precession, nutation, the influence of the sun, the moon, gravitational torque, and tectonic plate movement. How would quasars, why would we abandon the reasonable explanation that those are terrestrial phenomena that are being detected by VLBI because these are fixed to the surface of an Earth in motion in those ways? Why would we abandon that reasonable explanation for your explanation that it has to be those quasars moving in all the ways that would mimic that?
The assumption is that the more detectors you have, the more precise it's going to be. That's wrong. They all have to work at the same time and get the same measurement. And unless you do that, you're not going to get a precise measurement of what is moving. Okay, that's what we were talking about.
Atomic clocks. They're synchronized by atomic clocks, so they are in fact measuring at the same time.
No, they're not.
That's the technology. That's what it does.
Yeah, well, they have to communicate with each other. How are you going to determine that the communication between one space and another space is going to be precise enough for you to determine a result that the Earth is moving and not the stars?
They timestamp the data with an atomic clock, and then they collate it.
Yeah, well, why isn't the atomic clock affected by these movements?
Because why should it be?
Why should it be?
Yeah.
Because it's under inertial strain.
It's to a moving Earth. They're all moving together.
Let me tell you, okay? Because it's under inertial strain, and it's already been proven that atomic clock goes slower the higher it is off the Earth's surface.
Yeah,
so we have gravity and inertial forces both affecting an atomic clock. And you're saying that because there's a precision, this is exactly why we bring up the GPS in my book.
But Robert,
this is very important, okay? It is a fact that a GPS satellite that's shooting an electromagnetic beam from east to west is going to go faster than a GPS that shoots a beam from west to east by at least 50 nanoseconds every time, all day, every day, okay? What's causing that? Well, my explanation is that the fact that the universe is rotating around a fixed Earth, and it's thus carrying this beam with it, and that's why it's going to go faster east to west, because the universe is rotating east to west. Okay, so we know that these very sensitive instruments can be affected by rotation, by gravity, and inertial forces. So you're not going to get anything.
Are you saying then that VLBI, that the atomic clocks in VLBI are affected in exactly the ways that would then mimic things like tidal forces and precession and nutation and tectonic plate drift? And that's why they're seeing those kinds of variations?
Dave, how is a light beam going to give you tectonic plate drift?
Well, Bob, because you have detectors on different parts of the Earth.
How are you going to prove?
You're able to measure the distance between them by going off of a fixed
quasar.
All right, let's try to move on to the next question, because
miles away is going to be used to figure out a tectonic plate movement. I doubt it.
Yeah, let's move on to the next question, because I don't think that's kind of going anywhere. But I can tell you the fact that you do have atomic clocks measuring different because of altitude can be explained by relativity, because of the fact the frequency changes, right? I mean, you obviously, that's how atomic clock works. I mean, it's based upon oscillations. But let me try to bring us back a little bit to the conversation.
See, that's just begging the question, though.
But it does explain it. Relativity explains it. That's a fact.
Yeah.
Relativity will explain it.
That's not the period full stop after that day, Steve.
Okay, but hang on. Let's move on to another question here. I'm just saying it is, we all agree relativity can't explain it.
Yeah.
But
okay. Yeah.
When he was talking about earlier, and I have a question on this, about again going back to being parsimonious, and this is just something that I'm thought of. So maybe I could be completely wrong on it. If I am, fine. But when you're talking about something like the tidal, the equatorial bulge, right? We know that there are forces that cause something to bulge when it's rotating. We do experiments on the Earth. We know that's a fact, and we could use by analogy on a larger scale that will happen to the Earth. Now, yes, according to Mach, if the universe is rotating, would you have a similar thing? Okay, fine, right? It's a matter of perspective at that point. But it's kind of like this, though. If I was talking to Dave and I somehow put on a jetpack and I blasted up and I shot myself in the air, I could model that the whole universe is moving away from me just as easily as what you're saying. Exactly the same. I could take mine as a special place in the universe and say, I'm going to take all the transformations and put it around that specific point. And Galilean this time, because I'm not moving at the fast speed of light. But it is more parsimonious to say that I'm the one doing the moving. Would you not agree in that case?
Yeah.
Okay.
Because I never use that example about the universe moving away. I mean, I think that's a ridiculous way to explain it.
Sure. But by saying that the whole universe has to move around the Earth to explain the equatorial bulge, I think that's a similar analogy, because you're using far more assumptions than just saying, hey, we have a spinning ball that we can see. We can rotate it. We know that there's vector forces that cause a bulge there, and we can interpret that on a higher scale to the Earth. Dave, does that somehow now the analogy makes sense there?
Well, yeah, but I think you have to use your common sense here too. For example, let's say you're going to compare Earth to Venus. Venus's rotation has, in the last couple of years, has gone down by 6 minutes. Okay? What's causing that? A lot of things could cause that. The Earth's rotation hasn't changed. It's the same sidereal rate. If we go back thousands of years, it's still the same.
Okay. And that is absolutely false. That's absolutely false. VLBI technology that I just cited is documenting the decay in the Earth's rotation. And I'm just about finished with an article on this. They've just done some recent studies going back and looking at ancient eclipse data, finding out that the projected slowdown of this is actually showing up in shifting eclipse predictions in ancient sources, but it was just so subtle that the ancients weren't seeing it. So you're absolutely wrong about this. It is slowing down.
Yeah.
And the point about the equatorial bulge, it's a classic example of special pleading, because Venus rotates slowly and it has a small equatorial bulge. Jupiter rotates quickly. It has a large equatorial bulge. Earth rotates medium. It has a medium equatorial bulge. Why would I attribute, what rational reason that I have to attribute one to the entire universe and all the rest of them just to the motion?
And that was, wait 1 second, because I was going to follow up on that real quick, Robert, because what his point is exactly something else I was going to say. If you are pleading that the universe is rotating around the Earth in order to cause the bulge, why does that not hold to every other rotating object that we know of, including in the solar system of the universe? They all have bulges depending on their speed, right? The higher the speed, usually.
Of course, I never disagreed with that.
But does the universe revolve around Jupiter too?
No, it revolves around its center of mass. There's only one center of mass, and there's only one body that can occupy that center of mass, and it happens to be the Earth.
So the
So
universe is
there's-
the center of mass for the universe?
And look, I'm not making this up. Einstein himself said this. Mach himself said this. Any scientist worth his salt today will tell you that, because that's the way it has to be. If you believe in the general principle of relativity, this is the way it has to be, whether you like it or not.
That's not what
Okay.
Einstein said. And
Well,
here's what I
and
noticed, though.
the problem here is that you don't hold that, right? So they say,
What?
and there's an equivocation here, I think, in terms of how you use general relativity.
Mhm.
Basically, you're saying, oh, it allows for geocentrism, but it has to be put in quotes with a little g, because it allows for anything centrism, right? You can model that a child's top spinning 100 times a
We've already
second
been
is
through
the
this
center of the
game.
universe, and the whole universe is going around that. So you use
We've
this argument, but then you deny general relativity. So you cut away from it, and that's where the special pleadings.
Now,
And-
here,
and by the way,
let me clarify that for you.
okay,
I believe in the general principle of relativity. That doesn't require me to believe in the general theory of relativity. There are two different things. The general principle of relativity is a known fact in science. What happens with general relativity theory is they add all these accoutrements to the general relativity principle, and that's how it becomes a general theory of relativity, which is not what I believe in. Okay?
while y'all were arguing a second ago about the rotation, I just went ahead and looked it up so that we could, and because I was a little interested, but it's slowed down over the course of the past 100 years to add on about 1.7 milliseconds to a day. So it is slowing.
And even earthquakes can affect. Wait 1 sec. Even earthquakes can affect that as well, and have. I mean, usually
Yeah,
it'll.
and look, if you calculate the force of an earthquake or a tsunami or a volcano that happens millions of times a year, this Earth should have slowed down to half of what it's going now. But
Yeah,
it
there's no
doesn't
evidence
happen.
for that. But no,
It
that's
only
not true. But
happens.
we do notice, though, because of an earthquake, right, that the Earth has changed rotation. An earthquake, a tectonic plate activity, is not going to affect the universe, is it?
No, it's exactly the point.
Yeah, he's
Because
just talking about the Earth.
I think what we're seeing here is that the modern geocentrists, they have to hold certain things, and so they actually have to end up denying certain observational evidence.
that's bull crap, Dave. You know it. Okay? We have an explanation to it that you
Like I
just
see
don't
it.
like. That's the problem.
You're denying that.
Steve,
it's slowing down.
do we have any? Hold on, guys. Hold on 1 second, guys. Hold on.
David, look, you haven't proved
Robert,
that the
Robert,
Earth slows
everybody
down.
chill. Just
All
1
you
second.
did is say some lunar eclipse somewhere.
Relax for a second. I don't want to have to mute you guys. I don't have to
Yeah,
mute you guys.
the universe does
Steve,
rotate around Kyle. This is a
Steve,
fact.
Exactly.
Exactly.
Here anyway.
Yeah,
are there any
Kyleism. Go for it, Kyle.
Are there any other questions in the live chat? This has been a good debate so far, and I don't want it. I don't want to go so far that it goes off the rails and turns into something that it shouldn't. So this might be a really good spot to end it on.
Yeah, I don't think they really have too many questions. They were liking my questions. Obviously, some of these things do require a little bit of knowledge or understanding of the topic. This is not an easy thing to like dive into.
Okay.
All
Right.
right.
Now I'll let you guys take a couple minutes and wrap up your case, and then we'll close out the show. But I want to thank both of you for coming in and having this talk. Actually, both of you weren't on the original bill, so you both kind of stepped up for that. So we appreciate that. And Robert, we'll see you again on Monday for
Yeah, you get Dave.
mostly Dave. So we'll start with David. Go ahead and close out your case, and then we'll go.
I guess I would basically just kind of finish, the way I started, and that was to just point out that, we don't in scientific investigation, we don't say, so you're saying there's a chance, right? No matter how elaborate a conceptual kind of thing that I have to put together. So, I say that I have to have all these ad hoc and special pleading kinds of elements in my model, when a much more reasonable model is ready at hand. All that Earth has to do to explain this host of observational evidence is orbit the sun and rotate on its axis, just like any other planet. And that's why every single working physicist and astronomer in the last at least 200 years has not been a geocentrist, right? Because they all see that. And it's just reasonable. And so what I'm saying is that there's nothing that would compel us to abandon that view. Certainly my faith does not, the Catholic Church does not. I go into that detail on my site. And those of you who say, oh, come on, to Bob's point, I've heard that since I was a child, that, this is an insufferable problem for the Catholic Church. I think that I've addressed all of those points. That's not what the show was about per se. But I'm not compelled by my faith to abandon reason to hold this view. And therefore, I just say, I hold the most reasonable view. I don't have to go into all those other gyrations and backflips and ad hoc explanations to describe this. And so I don't. And I don't think anybody else should either. Bob, on the other hand, I mean, he's staked his reputation on this topic. He's staked his livelihood on this topic. But unfortunately, I think he staked his faith on it as well. And that's the part that's kind of tragic to me. And that's why I write on the topic, because I don't think anybody should do that. I don't think that they should feel compelled to do that. And that's the part of Bob's work that I really object to, is that he links this to the faith, and it's not reasonable. And the Catholic Church has basically said that we're to hold our reason and our faith together, and we do. And this is one of those areas where, I think that hopefully I've tried to demonstrate that there has to be all this denial of actual observational evidence, and also really convoluted explanations of observational evidence when there is just a reasonable, parsimonious explanation near at hand. And that's been my argument tonight.
Okay, and go ahead and give people the name of your blog one more time.
Yeah, it's geocentrismdebunked.org.
Okay, and now Robert, we'll close out with you.
Sure, thank you. Dave has just given me some talking points, so I'll wrap up with them. Yeah, I attribute it to my faith in the Catholic Church because, and Dave never addressed this, and I don't think he does a good job of it at all. The fact is, the Church condemned Galileo for believing in heliocentrism, called it a formal heresy, and decreed that he was suspect of that heresy. That was by 2 popes, and in the 1600s. The fathers before us also believed in that. So there is a precedent for the fact that geocentrism was a matter of faith because the Church declared it so. And the imprimatur that Dave mentioned in 1820 that was given to Canisatelli has no effect on this whatsoever because it was just an imprimatur, and imprimaturs don't give official doctrine. The last official doctrine the Church gave was that heliocentrism was condemned, and the Church has never changed that. There may be an unofficial opinion out there that heliocentrism is better to believe in among some people in the Catholic Church, but that doesn't change anything. The doctrine is the doctrine. That's what the Church gave us. If you talk to any scientist out there today, he will admit that, as a matter of fact, I quote it. There's this other guy I just ran in the other day, Siglar is his name. He said, yeah, I don't like geocentrism, but I have to admit that it works, and it's a much more simple system because we don't have to invoke inflation and the Lorentz transform in order to make it work. We can just have a simple universe going around a fixed Earth, and it's very simple, and that's all there is to it. But he didn't prefer it. Why? Because of his philosophical presuppositions. Because if the Earth is in the middle of the universe, the very center around which everything revolves, like I said before, that means that there is no time and chance to the fact that we are here in this very place. If I were an atheist, I would do everything possible to get the Earth out of the center of the universe. Because if it is in the center, I know that it was by design. And I'm going to have to answer to that person, whoever put it there. This idea that, we have special pleading and all this, and we deny observational evidence, that is just totally false. I don't know where David is getting that. Every piece of evidence out there, we've answered it. He just doesn't like the answer. And the reason he's not compelled or motivated to this is because he doesn't believe it's a matter of faith in the Catholic Church, but he has no reason to go in that direction because the Church did declare it. And the highest authority that the Church gave showed us that the Earth is not moving and is in the center of the universe. So how can it not be a matter of faith? Bellarmine told Galileo, he said, look, if Scripture errs in one point, it can err in another point. And basically the whole thing is not worth the paper it's written on if that's the case. That's where the Church stood. And that's where I stand. That's my motivation. And I use the science to prove it.
Okay. And where can people find out? I know that you've got this will be more relevant on Monday, but you've got a new book out. Where can people go to find out more about you?
Yeah, let me show you that book here, flatearthflatwrong.com, and they can get that at flatearthflatwrong.com.
Easy.
Yeah, easy. And we have a $10 PDF they can buy, or they can buy the book, a little bit more expensive. They can also go to our website, journeytothecenteroftheuniverse.com, and they will see all the stuff we have for sale to know about the Earth in the center of the universe. And of course, there is also the Principal website, theprincipalmovie.com, that they can go to see all the things about our movie that came out in 2014.
Cool. All right, Steve, I know you got one more super chat you want to read. You want to go ahead and knock that out of the way?
Yeah, Zero had asked, why is the CMB red shifted in one direction and blue shifted in the other if the Earth is immovable at the center? However, I don't think we're gonna have time to really get into that. So maybe, some future time, if we want to talk more specifically about the anisotropes and the axis of evil and how it seems to have a relative direction to us, I think it's quite a bit.
Universe is rotating east to west. That's what we would see. We would see a blue shift on one side, red shift on the other.
I think that's a great topic for another discussion if we get some people to actually come in and dive right into that. But
you'll be seeing more of Robert on
Robert on Monday.
On Monday with allegedly Dave. Just remember, guys, tomorrow we have Tim O'Neill back. We will be going through. It's often stated that Christians are the reason that the Library of Alexandria was burned. Tim O'Neill says that's not the case, and he will be making a case for that tomorrow in his show. That'll be at 8:00 Eastern. So make sure that you join us for that. Steve, are we doing an after show?
Yeah, I think I will be, maybe in about an hour. I listen to some of these voicemails before we do that. And I did send them to Dave. I think I've heard them all, but I don't know what order they're in. But if you guys are interested in the saga that's going on with my crazy ex-roommate, I think that'd be a perfect addendum for this particular after show. But I do want to talk about this after show, a little bit about the topic, but that won't be for about another hour. It's hot. Everybody's hot. We need to cool down. But I do want to thank both you guys for coming in, especially Dave. This was, a back and forth for us to make this happen, and Robert, to you as well, because obviously none of us agree with you, but I like the fact that you come in and answer questions, and I do appreciate your honesty in the question that I asked you. I appreciate how you answered that question. I really do.
Great.
All right. Thanks, gentlemen.
Take care.
Good night.
Bye-bye.